part 4 is very short. We're just going to go over the idea of electric power and how to do electric power calculations. So we've talked about power before. Power is work divided by time, or the rate at which we do work, or energy divided by time. Because when we're doing a light bulb, it doesn't look like we're doing much work, but we are using energy. So the rate at which electrical energy is converted into another form. And so, right, so power is energy or work divided by time. Now, for electrical devices, power is equal to current times voltage. So when we have a 100 watt light bulb, because of course light bulbs are measured in watts, that's the power. Now, if you look at this light bulb, it says 100 watts, but down below it, it says 120 volts. So it's only 100 watts if the voltage is 120 volts. So let's go see how that works. So we can find out how much current this light bulb is drawing. So since power is current times voltage, then current is going to be power divided by voltage. And so our power is 100 watts. The voltage is 120 volts. And that gives us 0.8 amps of current. Okay, so anyway, so we can use the equation power is current times voltage, or voltage times current, either way, to find a voltage, to find a current, or to find power. Now, sometimes people like to play around with this because they put in Ohm's law. Remember, Ohm's law was V equals I times R, is one way to write it. So in this equation for power is current times voltage, we could put in for the voltage Ohm's law, V equals I times R. And then we end up with an equation I squared R. Or we could say, okay, well, we could substitute in Ohm's law, but we could substitute in the form that says current is voltage divided by resistance. So we, instead of substituting for the voltage, we substitute for the current, which is voltage divided by resistance. We're multiplying by voltage, so we end up with V squared over R. Now, why do we care? Well, sometimes you might have a homework problem where it asks for the resistance of a device, and all you're given is the voltage and the power, for instance. So let's say that I had a 100 watt light bulb and the voltage in the house is 120 volts, and I just want to find the resistance. Well, I could go back to here because I already figured out the current. So now I've got the voltage and the current, and I could figure out the resistance. So a two-step process. Or I could just jump right to this equation, solve it for resistance. So the resistance is going to equal the voltage squared divided by the power. And my voltage was 120 volts, which is going to get squared. And I'm dividing by the power, which was 100 watts. And now I can just do that equation. And end up with 144 ohms of resistance. So I was able to get the resistance. I didn't have to figure out the current. I could have done it that way. In physics, there are often several different ways to do the same problem. But anyway, I was able to use this handy-dandy equation. So you don't have to use these handy-dandy equations, but some people like to know about them. Now, the main thing that you need to learn, though, about power for your homework and for the test is about kilowatt hours. Okay, so the idea is we want to find out how much energy gets used. And remember, we're talking about how power is energy divided by time. So energy is going to be power times time. Okay, now let's go back to how we would normally do that in a science class. And we would say, okay, power would be in watts. And if I multiply by time in seconds, then that's going to give me joules. Perfect. Okay, except when you are paying your electricity bill, they don't charge you for joules because we're in America. I don't know what they do in Europe, but they definitely don't charge you for joules here in America. Instead, they charge you for kilowatt hours. So if you go out back in your backyard, probably it's in your backyard, maybe in your side yard, and you find your electrical box, and you will see these cute little dials zooming around as you use electricity. You could try turning off everything in your house. It would still probably be going, because when you turn things off, often energy vampires are still lurking, like anything that has a blinking little red light, still using electricity. And of course, your refrigerator's on. You're not going to turn that off just for this experiment. So anyway, so it's very hard to stop using electricity. But anyway, what's a kilowatt hour? Well, seconds was too small. So we use electricity for hours and hours a day. So the power company charges us for hours of kilowatts, thousands of watts, because we use a lot of electricity. So your monthly bill has a number in kilowatt hours. Okay, so instead of doing things the sensible joule way, instead what we're going to have is kilowatts times hours. And that produces the unit called a kilowatt hour. All right, so let's do one. So the question up above says, how many kilowatts of hour or of energy is used when running a 1500 watt blow dryer for 20 minutes per day for 30 days? Okay, so there are a couple of things you need to do. You need to figure out the time in hours, and then you can figure out kilowatts if you want to. All right, so let's try this one. So let's figure out the time. So the time is 20 minutes a day for 30 days. So the time is going to be 20 minutes a day. So you can just do this by going 20 minutes times 30 days. And that's going to give you 600 minutes. And that's going to be, of course, 10 hours, right? 600 minutes is 10 hours. All right, so now you've got your time in hours, which is what you need. Okay, and then you can have your power in kilowatts. Well, 1500 watts is going to be 1.5 kilowatts, right? So your formula would end up being power 1.5 kilowatts times your time in hours, which was 10. And so you would end up with 15 kilowatt hours. So if you were only paying 10 cents per kilowatt hour, then this wouldn't cost you very much at all, right? So 10 cents per kilowatt hour, you would be looking at $1.50 there for all your blow drying. Maybe electricity is too cheap in this country. Anyway, so that is how this works. Let's do one more, taking a slightly different approach to it. How many kilowatt hours of energy do you use by leaving a 60 watt light bulb on for 8 hours a day per day for a year. Okay, basically the same thing. We need to figure out the time. And so this case, the time is going to be 8 hours per day times 365 days in a year. And so 8 times 365 is 2,920. Okay, now, in this case, the light bulb is only a 60 watter. So rather than making it into kilowatts, we're just going to leave it as is for now. So we're just going to put in 60 watts times the 2920 hours. And so now I've got 175,200, and this would just be in watt hours. So now to turn it into kilowatt hours, I just need to divide by 1,000, which is easy at this point, right? So I'm going to end up with 175.2 kilowatt hours. Okay, so at this point, divide by 1,000. So you can divide by 1,000 at the start to make it kilowatts, or divide by 1,000 at the end to convert it to kilowatt hours. Okay, so anyway, so you've got a couple of those problems in the homework and in the test and the quiz, so make sure you're ready for them. And that is the end of this chapter. All right.